Hello everyone and welcome back. So while we are still here in this Errata for session number 5, there's one more thing that Lee would like to do, and this is going to take place over the next few videos, and that's throw some more optimization in. Now for those of you that have already spent some time and you've optimized your noise class, feel free to skip these videos, or of course if this is stuff that you're very comfortable with, feel free to skip them as well. But for those out there that are new to working with C#, and we know there are quite a few of you in the class, we will go ahead and record these videos and just put them up there. So they're just extra content if you want to look through and see how they are optimized. Now, Lee tossed out the challenge for anyone that was in the class that wanted to take a look at getting everything streamlined that was in the noise class that he put together. And Tim, Dark Issues on the Site, a friend of mine from back at the Renaissance Center back in the day, sent his results to Lee to come up on the challenge, and they were some pretty interesting results, huh, Lee?
Yeah, I knew that they were going to be substantial, but I wasn't quite expecting the results that were coming out of the optimize of the Perlin noise itself.
Okay.
And in most cases, though, Perlin was running as fast or faster than value in simplex noise by the end of it. But then when I went and looked at the actual code, it's not really that surprising when you look at it. So if I
let me go ahead and
jump
help
over,
you.
yeah, thank you. So if you look at the things that we were talking about, particularly in the 3D Perlin noise, we were talking about unrolling or inlining the dot products and the lerps. If you look at the 3D noise, there are 8 different dot product calculations, and there are 7 lerps. So each one of these is being calculated through every pixel that we're generating for our noise. So we are calling another method, 7, 8, that's 15 times, to do calculations that we could do very easily inline right here and save all that time.
Right.
So this is the heaviest of the leaving the method to calculate a number. So it only makes sense that it has the largest amount of optimization that we get back when we start inlining it. And 2D's similar. We end up with 4 dot products and 3 lerps. So we will be going through, and like you had brought up, I had challenged you guys to unroll these because not unroll them, you unroll loops, but I challenged you guys to inline these in one of the previous videos because it was something that I was going to do with my library, but I wasn't going to take the time to do it on video. But Tim went ahead and did it, and he PM'd me, and then Saradak, I believe, has got a thread in the MMO class as well where he had posted the performance updates that he had gotten as well, but he didn't know that Tim had actually beat him to it. So Tim gets the credit for being the first one. Saradak was the first one that posted his results into the website, and I'd like to thank him for that too. He actually put up a little web app that people can play, so he called it the little noise toy or something like that.
Very cool.
Noise toy. So just to play with, he added a couple little features, so I wanted to give him credit as well. But because there was only a couple of people that had gone ahead and did it, I was figuring there's a lot of people out there that haven't run through these optimizations, and they are something that are very important to do. So I wanted to have the videos in place so that everybody has the most optimized noise that they can get, because the more noise calculations we do in the future, you want them to be fast. These are things that are going to be run hundreds, thousands, millions of times, depending on if you're updating every frame, how big the texture is. So it only makes sense to make sure these things are fast.
Right.
And at some point, we're probably going to take this library and bake it out, yeah. Been thinking about lighting all day. But we'll be building it out as a DLL. So it'll be a little library, and the way this was written, it's all in C#, and it's written in a way that it is not reliant on Unity. So you'll be able to take this DLL that's been completely optimized and use it for any project that you need noise for. So it just makes sense to make it sure that you've got all the optimizations. So if you haven't done it, I definitely encourage you to make sure that you inline all these dot products and lerps. So with that being said, we're going to start off with the value noise in this system. But
In
before
this
we
system
start,
or
or
in this
well,
video?
in this video,
Oh, okay.
this video about this particular algorithm about the noise system. Did I recover that, or did I just ramble?
I think you rambled, but it's okay.
Yeah, well, it is what, 20 to 5 right now?
Yeah, something like that. So basically in this video, you're going to go ahead and take care of both 2D and 3D value noise.
Right, because there's only a few in value noise. Value noise calculations are fairly simple, so we've only got 3 lerps to be inlining in 2D, and we have 7 inside of our 3D. But even before we do that, I want to get some benchmarks. It's kind of hard to optimize if you don't know where you're going from, so or where you've come from to where you are going to. So you never know. You could have done something that made it run slower. So, but if you haven't written down those numbers, you won't know. So I'm going to start off with 2D noise. So I'm going to go ahead and delete our iterations. Now, if you remember, our get values has 2 overrides. The first one is for 2D noise, and the second one is for 3D noise. So let's get our 2D noises values first. And I'm going to do this all at once instead of doing it in each video. So it'll just save time. And we've got that really cool interface. So we can quickly get the numbers down for each one. And if I go ahead and hit play. Now, if you don't mind, could you pencil these down until I switch over to Notepad?
Sure.
All right, so our value noise 2D is coming in at about 30 to 35, depending. It looks like 34 is the average.
So let's say 34.
Okay, so 34. Perlin is 55. Oh, it's going up. 50, yeah, 55.
Okay.
And Simplex is bouncing all over the place, but it looks like about 47 to 50 when it's averaging. So, call it about 49 right in the middle?
Sure.
All right, so that's our 2D numbers. So go ahead and stop running that. Go back in the code. Undo what I had before. That puts the iteration back in, which then uses our 3D override. And then we'll go ahead and run it again. So let's start off with value. Value is coming in at about 54.
Okay.
Perlin looks like 85. And Simplex looks like about 56. All right, off camera, I've kind of set up a little chart for us. So value noise is coming in at what for 2D?
Is 34.
Okay, so 34. I'm going to line this up for our next number. Perlin is
55.
Simplex
Is going to be 49.
and then value for 3D
Is 54.
Perlin.
85.
Boy, that one's really slow.
And 56.
And 56. Okay. So that gives us our before numbers. So now that we've got a place to measure any improvement from, let's go ahead and look at how we can inline a lerp operation. Now, basically, all a lerp is a blend between the first value and the second value by a ratio or a percentage that is a float value from 0 to 1. So to achieve that, we can do it by taking value 1 and adding the difference of V2 minus V1 multiplied by the ratio. So what ends up happening is we take our second value, which is the higher of the two numbers, and subtract the first value from it. So if V2 was 10 and our V1 was 2, 10 minus 2 is 8. And if our ratio was 0.5, we would return out we'd return out 4, which is halfway between our 2 and 10. So, and if it was 0.25, it would be 25% between. So if we had 8, it would be 2 plus our original value, so we'd get 4 in that case. And it would be 6 the other way. I said it wrong because it's 10 minus 2 gives you 8. 0.5 would be 4 plus 2 gives us 6 for our first case. So to make this work, we're going to use this formula instead of calling these lerps. So what I'm going to do is get rid of the lerps. The first number is going to be our V1, second number is going to be V2, and our third number is going to be the ratio.
How about throw the that whole example and just throw some slash marks at the beginning, toss it into a comment.
Just so we don't get the error?
Yeah, just there we go.
Okay. So our V1 is going to be the first number. Well, actually, we want the higher number. NHL is going to be our second number. So I said that backwards, my bad. Second number is going to be V1. First one's going to be V2. So V1 will be NLL. To that, we're going to add the difference of NHL minus NLL times U. Subtract that out, or subtract it out, comment it out. Put a semicolon, end it, and then comment out the rest.
There you go.
I can speak English, really. All right. And then it's the same premise for all the other ones. So I can comment it out and then go. So this will be our first one, NLH plus, what's the second one? NHH minus NLH times U. So this one will be NYL plus and NYH minus NYL times U, semicolon. Now the nice thing is, let's clean this up so everything is consistent. I'm just going to leave those down. Wow. Keyboard failure.
Gotcha.
Nothing to do with the operator. The nice thing is these are exactly the same as the first couple of these ones up here. So I could paste those in. Or they're not, that's right. Nice. It's like going, yeah, they're exactly the same. No, they're not. All right, let me get my formula here. That's going to be exactly the same. I can't even copy and paste. Wow, awesome. All right, so same premise down here. And I'm just going to comment out all these. So NLLL plus NHLL minus NLLL. And who came up with these names?
I have no idea.
Yeah. All right, so NLHL plus NHHL minus. Worst part is you got to get them exactly right, because if you mess them up, your noise is going to be really bizarre, if it works at all. Wow, that was good. All right, 3 more to go. Wow, I still can't type. All right, we're almost in the home stretch. So now, same formula, NYLL plus NYHL minus NYLL. Except these are times V. You're supposed to be catching this stuff. What happened?
Yeah, I don't know. All of these incredible names blur together, you know.
Is that what it is?
I think so.
Yeah, this is what happens when you try to keep it consistent with other examples. I personally like the one that used, N followed by a sequence of zeros and ones. Those were fun too. Really fun when you're trying to learn this stuff for the very first time too. It's like going, what is this? So, NY and XY. All right. So, no errors. Let's see if it actually still looks like noise when we run it. That'll be the first test. So if we go ahead and run, yeah, it looks like noise, except that's simplex. So let's switch over to value. Yep, that still looks like noise. And it's animating. So that looks good. We also have a time of 35 milliseconds.
Mm-hmm.
So, and if I look at code, game manager, we are using the 3D version. So 35 for 3D. Kill out that line. Let's run it against the 2D version. And seeing as how that doesn't look right, I'm
Whoa.
on the bet I messed something up. Well, it's pretty cool if we were trying to procedurally texture, say, the side of the Death Star.
Yeah, this is true.
So let's go look and see what got messed up. which is why it's important to go back and test everything. Man, you missed it again.
Yep, I sure did. I'm fired.
Yeah. It's kind of hard. You're this like CEO, isn't it?
Yeah, I'll fire myself. Don't worry about it.
Oh, okay. You take care of that.
Yep.
Because I hate firing people.
All right, so 24.
All right. So 24 and 35. So 24 and 35. Well, those numbers are definitely less than what they were before.
Oh, yeah.
So that's a good sign. So let's get out the handy dandy calculator. So if we take 24, divide that by 34, we get 70.5 now. Trying to remember, that would be negative plus 1. So 29.4%.
Okay, we know the rule. We don't ask me any math questions.
Oh, yeah, I'm sorry, I forgot.
Especially as it gets later and later throughout the night.
Well, we could do it, let's see, 34 divided by 24 times it by 100. So it's 141.6% faster.
What?
Depends on how you want to calculate it. So, but 24 divided by 34 is 70.5. Wow, for some reason I can't remember how to calculate that, but it is. Wow, that's really bad. 24 divided by 34. We'll get there. No, I did that before. Subtract that from 1. Okay, so 29.4%. We'll have to, PM Tim tomorrow and ask him how to do percentages.
Oh, you can. I don't care about math.
And just think, I'm writing all the trade stuff that has all that math in it. And you want to know why the R&D takes so long. Okay, so 35 divided by 54. Negative plus 1 is 35.2. Well, it took me less time to optimize the code than it did to calculate how much it optimized. All right, so, but still, 30% and 35%, that's a worthwhile optimization. So, and that was only by inlining stuff and getting rid of the method calls. Even that little bit is, and actually, when you think about it, even these ones are even greater performance increases than we had from the other optimizations that we did. So
yeah, for sure.
Go ahead and move that out of the way. Stop this down. So, but that takes care of the optimizations for the value noise.
Okay.
And in the next video, we can tackle the Perlin noise, which is going to be a little bit more complicated because not only do we have to inline the value or the lerps.
Yeah,
here,
we've got some dot.
We've got to handle dot products.
That's right.
Which get a little bit more complicated, but they're not that difficult. So.
All right. Well, with that, that is going to wrap up this video. Thanks a lot.